side of the wire. I'd like to thank Ms. LaDonna Renee for coming out and dedicating your time to us. Also, I'd like to thank everyone for listening. What my project was, I guess because the light, you can't see my light bulbs are bright, but then what I did was I figured out like path of electricity out through. So if you unscrew a light bulb and they all go out, it's a series circuit. If in that right one I unscrew the light bulb and they all stay on, that's a parallel circuit. A problem statement was an inspector comes into a room, maybe like this one, and all the drywall has already been hung, and he has a bunch of different lights. So it's a 5-light circuit, or it could be devices. It could be you have a TV or a cell phone or something charging or something like that even on them. When I say a switch is missing, or when I say it's off, that means a wire is missing. So when the switch is off, the wire is missing. Like there's a bunch of different wires running through here. So it's like one is missing. Next, voltage is the potential energy per electron. That's one of my definitions I'd like to share. The other one is there are a bunch of different electrons coming through my circuit right now. So it's the electrons going through the circuit per second. We bought some materials on a budget. We had some, and then we actually built this whole circuit. We used something, one of the things we used was, you see there's a bunch of white wires going through here. There's a black wire inside of that, a white wire, and a ground wire. And then we used a device called a stripper, and we wrapped it, we put it around there, and we sort of twisted it and then pulled it off, which pulls off so there's some of the wire there showing. And then after that, we connected it to the monolith here, I did, and we connected it to the screws, and we screwed it down. Then we had to screw down all the boxes and screw the light bulb holders on, and we had to have all the light bulbs and everything. And then we also did the board and stuff. Next, I had my hypothesis. I predicted whether it was, in part one of my hypothesis, I predicted whether it was parallel or series. We chose 10 of the circuits. There are a total of 16, but we just did 10. So we did, and then we did voltage and current. We predicted which had the voltage constant or the current constant. Something that may have affected my, like in the hypothesis, my results was every time it was parallel, I predicted voltage was constant, because in a parallel circuit, voltage is always constant, and in a series circuit, current is always constant. In part 3, I ranked the power, so from a 1 to 10 scale, I ranked for each one, I ranked the power, what it was. In my introduction, I'd like to share a couple of points I had. You can come up and read it on my board when you come around, but a couple of points were, first, the independent variable in my project is the switches. So when I turn on and off different switches, from the perspective of the project, if you were the project, think about the independent variable, you're not controlling it. The dependent variable is dependent upon the project. If you're looking from the project, is dependent. So one of the dependent variables is the voltage, as I said. You unscrew it as series, or you unscrew it and they all stay on parallel. Next is the total current. Please use a device called a kilowatt for this. You press the button that says amps, you plug a plug in here, and you plug this into an outlet. That tells you the total current going through the circuit. We also use a multimeter. Of course, this circuit isn't a live circuit, but if it were, you'd put one probe on here and one probe on here. And on this screen, it would tell you the total voltage for a light bulb. All of the light bulbs in a series circuit add up to 120 volts. All the light bulbs in a parallel circuit average to 120 volts. Next, we use the kilowatt meter again to find the total power in the whole circuit. For my conclusion, we found that if one or fewer switches were off, so if you have a few, but you only have one switch off, it's have 2 plus switches off, so if I have 2 switches off, it's a, if I have 2 switches off, it's a series circuit, so you unscrew it in series. Some exceptions to this are when only A is missing, there's only one lit, so you can't find whether it's series or parallel, because if you unscrew it, it doesn't, none of the other light bulbs are on. And also the exceptions are DA, D, AC, and BD. Finally, in my hypothesis, some of the problems I ran into for my results were, with my hypothesis, were I predicted when the parallel, there were some that were only one lit, as I showed you, so that was one of the problems. Next, I predicted I predicted a lot of parallels. I only predicted that one was series in my hypothesis, so that was wrong too. Next, for the voltage, I predicted everywhere that if the voltage or current was constant, I predicted for every parallel voltage was constant, for every series current was constant, so that's the one other problem, because from the part one, it's sort of goes together. And then ranking power, I was off in some and I was on. It was sort of just throwing out your best guess out there, because there's no really good way to throw a hypothesis out for that. Then I did my research paper. I had 2 paragraphs for that. First paragraph is the way a house is wired. Every house is wired in a parallel circuit. It's the ideal one is for this really bright one, because if you turn off maybe your TV or your phone or something that you have in there, or you turn off something else, everything else stays on. That's to a series. If you turn off your phone or something, everything goes out, which would be really annoying every time. Also, you notice there's a lot of power in here, because they're very bright. Next, my second research paragraph is the common features in a modern house. First one is the electric meter. The second one is the circuit box, and I explained that in my research. I have all my solutions to my project, all 16, as I said, in my circuit solutions. If you'd like to read through that, I'd like to show you one thing. If there's a line going directly through a letter, that means that switch is on. If the letter is in just a white area and there's a black line or dotted line just going up, that means that the switch is off or missing. My solution, there are a bunch of different solutions. As I told you, there are 16, but if it was in a 5 inlet one, first you unscrew one, and you find it's a series circuit. Next, you test the volts per light bulb, and that would add up to 120. So ideally, they each be 24. Now, that's not always the case, but ideally. Then you do the current per light bulb and the total power. If you average out the current per light bulb and then average out the total power, in the series, it would